In this example, we're going to be using a table that was provided to us in the book. And this table has important Maclaurin series and their radius of convergence. Remember that all of these can be derived by applying the formula f of x is equal to sigma as n goes from 0 to infinity. The nth derivative evaluated at 0 over n factorial times x to the nth power. So we're going to use the Maclaurin series for e to the x. I want you to notice that the radius of convergence is infinity. So if we're going to use the Maclaurin series for e to the x, to obtain a new Maclaurin series for this function f of x, which equals to e to the 3x minus e to the 2x, then what we're going to do is we're going to start by getting the Maclaurin series for e to the 3x. Let's begin with e to the x really quick. So e to the x is equal to, again based on the table, sigma as n goes from 0 to infinity, x to the nth power over n factorial. And if we were to expand this, we know we have 1 plus x over 1 factorial plus x squared over 2 factorial plus x to the third power over 3 factorial, and then the idea will continue. For our problem, what we want to do is we want to get the Maclaurin series for e to the 3x. So we're going to go to our formula, and instead of x, we're going to plug in 3x. So this will be equal to sigma as n goes from 0 to infinity of 3x to the nth power. So this will be, instead of every x that we wrote earlier, we're going to write down an e to the, e to the 3x, which is sigma, again, as n goes from 0 to infinity of 3x, the whole thing to the nth power over n factorial. The other thing that we want to do is look at e to the 2x. And if we are looking at e to the 2x, then e to the 2x is going to be equal to sigma, as n goes from 0 to infinity, of 2x to the nth power over n factorial. And again, this is going to be equal to 1 plus 2x over 1 factorial plus 2x to the third power, or 2x squared over 2 factorial plus 2x to the third over 3 factorial, and then the idea continues. So now, since we are looking for f of x, we can say that f of x is equal to e to the 3x minus e to the 2x, which is going to be equal to e to the 3x. Well, e to the 3x, if we decide to expand, e to the 3x is nothing other than this part here. Let me actually get a... So e to the 3x is that. And then we're going to say minus e to the 2x, where e to the 2x is nothing other than this. Let me move things over a little bit. So the idea here will continue. What we want to do now is we want to simplify whatever it is that we need to simplify. So in this case, you can see right away that 1 minus 1 becomes 0. And then I'm going to write it down as 3x over 1 factorial minus 2x over 1 factorial. Let me put that in parentheses. I'm going to put plus 3x squared over 2 factorial minus 2x squared over 2 factorial plus a 3x cubed over 3 factorial minus a 2x cubed over 3 factorial, and then the idea will continue. We can simplify this a little bit more, and we can write it down as 3. I'm going to leave it as 3 minus 2 over 1 factorial times x plus 3 squared minus 2 squared, and I'm going to leave it like that, over 2 factorial times x squared plus, let's write it down as 3 cubed minus 2 cubed over 3 factorial times x to the 3rd power, and then the idea will continue. We can write this down using sigma notation, and we can say that that is equivalent to sigma as n goes from, we'll start it at 1, as n goes from 1 to infinity of, we can say 3 to the n minus 2 to the n over n factorial times x to the n. So f of x is equal to this series here. Now, the other thing that we have to do is find the radius of convergence. We can do the work using any of the tests that we've talked about before, or you can go back to the table and remember that for any exponential graph or any exponential function, the radius of convergence will always be infinity. So if the radius of convergence will always be, or is always infinity, then that doesn't change here. The radius of convergence is infinity. And then in case we needed to write it down, the interval of convergence is going to be from negative infinity to positive infinity. And do you remember what the center of this series is? The center is automatically 0 because we're talking about the Maclaurin series. I want to do this one more time. We're going to say that f of x is equal to e to the 3x minus e to the 2x. And remember that e to the 3x, we can write it down as sigma as n goes from 0 to infinity. And then we can say this is going to be, remember, we have it here as, we have it here as 3x to the nth power over n factorial. And then let me say minus, and now e to the 2x, where e to the 2x is sigma as n goes from 0 to infinity of 2x to the nth power over n factorial. So if we continue here, we have sigma as n goes from 0 to infinity of 3 to the n x to the n over n factorial minus 2 to the n x to the n over n factorial. And if we wanted to simplify a little bit more, you have 3 to the n minus 2 to the n over n factorial times x to the nth power. These two answers are the same. And I know one of them starts at 0 and one of them starts at 1. But if we let n be equal to 0, you have 3 to the 0 minus 2 to the 0 over 0 factorial times x to the 0. So the numerator here will be 0. So the very first term in this second series, the very first term is 0 because we just checked the work, and that gives you the same as the answer that we had before. I'm sure you've noticed by now that I did a different problem here, so I'm going to try to do 2 examples in this video. So if you need to take a minute, go ahead and pause. And I will start this next video here. So what we want to do one more time is find a Maclaurin series using the table that we talked about earlier for this function. Okay, so we're going to use the Maclaurin series table to obtain a new Maclaurin series for this function f of x. Well, for x equal to 0, the answer is 1/6, so there's not much work to do there. But we do have to look at the first part. What happens if x is not equal to 0? So if x is not equal to 0, then f of x is equal to x minus sine of x over x to the third power. The first thing we're going to do is figure out what is sine of x. So go to the table and figure out what sine of x is. And we can say that sine of x, let me erase this here. We can say that sine of x is equal to sigma as n goes from 0 to infinity of what you see there. And then one more time, notice that the radius of convergence is infinity. So since we have sine of x to be that, why don't we write it down? So we have sine of x is going to be equal to sigma as n goes from 0 to infinity, x to the 2n plus 1 over 2n plus 1 factorial. And we know that this will expand to be x to the third. So if you let n be equal to 0, you have x to the first power, not to the third power, x to the first power over 1 factorial. And then we're going to have minus, so let me finish copying the formula down. We have negative 1 to the nth power. And then we are going to have a minus x to the third over 3 factorial plus x to the fifth over 5 factorial minus x to the 7th over 7 factorial, and then the series will continue. So when we say that f of x is equal to x minus sine of x, then this is going to be the same thing. I'll worry about the denominator in a second. It's going to be x minus all of this stuff here, because that's your sine of x. You agree? So you're going to have x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, and then the idea will continue. And then the next step will be to divide by x to the 3rd power, because that is what the problem has. So we're going to divide by x to the 3rd power. Well, in your numerator, you can simplify the x's. X minus x is just 0. And then you have a negative. Actually, let me first put, we're going to distribute the negative signs. And then the other thing is this over x cubed. I'm going to write it down as 1 over x to the 3rd times, and then we're going to have x cubed over 3 factorial minus x to the 5th over 5 factorial. So I changed the division to multiplication of the reciprocal. And then we're going to have plus x to the 7th over 7 factorial. And then if we were to continue, minus x to the 9th over 9 factorial. And then the idea continues. So when you multiply each of those terms by 1 over x cubed, then you have 1 over 3 factorial minus x squared over 5 factorial plus x to the 4th over 7 factorial. And then we're going to have a minus x to the 6th over 9 factorial. And then the idea continues. So we need to write this down using sigma notation. So we can say sigma as n goes from, we can start it either at 0 or at 1. Why don't we start it at 1? And if you start it at 1, your denominator, or in general, your denominators, the 3, the 5, the 7, the 9, 11, and so forth, we can say that that is equal to 2n. We're starting at 1, right? Plus 1 factorial. So when n is 1, you have 3 factorial. When n is 2, you have 2 factorial. When n is 3, you have 3 factorial. And then the idea continues. So let me put here, n is 1, n is 2, n is 3, n is 4, and then the idea continues. I also want you to notice that we have alternating signs. So since we have alternating signs, we know we're going to have -1 to the, in this case, since we're starting at 1 and we need the first term to be positive, I'm going to write it down as n plus 1. And then you can, again, plug in the values for n and figure out what do you get. We're going to have x to some power. So this is where we need to make sure that our lower limit is correct, and if not, we change it. And then we also need to make sure that our terms will match both in the numerator and in the denominator. So we can put, if we're starting at 1, we can put x to the, let's see where that takes us. If n is equal to 1, if if n is equal to 1, and then this will be the power. And then here we'll put the formula. So n is 1, 2, 3, and 4. So we have powers of the power of 0, 2, 4, and 6. So we need to come up with a formula. So we can think about 4 and 6 as 4 times 2 minus 2. We can think about the relationship between 3 and 4 as 3 times 2 minus 2. We can think about the relationship between 2 and 2 as 2 times 2 minus 2. So you see, going back, 8 minus 2 is 6, and that gives you the same number. 6 minus 2 is 4, and that gives you the same power. 4 minus 2 is 2, and again, I apologize for the dogs. That gives you the same power. And then you have 2 times 1 minus 2, which is 0. And one more time, that gives you the same power. So we can think of the power of x as being 2n minus 2. And this right here is your function f of x when x is not equal to 0. The last thing I want to do is talk about the radius of convergence. The radius of convergence will be infinity because the radius of convergence associated with the sine graph is infinity. And what we can do if we wanted to is we can apply the ratio test and determine for what values of x does this series converge. And once you do all that work, then you'll see that the radius of convergence is infinity. That is, this series will converge for all values of x. All right, I'm going to stop here.